Hello everyone, in this video we are going to solve problem 28 of chapter 9. Locate the centroid of shaded area. So the centroid equation for an area is x bar x tilde dA over dA, y bar is y tilde dA over dA. X tilde and y tilde are the centroid of our differential element. Because we want to find the centroid of an area, our differential element should be an area as well. So I'm going to select this rectangle as my differential element. It's not a perfect rectangle, but because differential element is a small area, we can assume it's a rectangle. My first task is to find the center of this rectangle, because the centroid of a rectangle is its center. So x tilde and y tilde. The x tilde would be simply the coordinate of x. Y tilde would be the average between y1 and y2, because the bottom of this rectangle is described by y1 and the top part by y2. So if I want to find the center, that would be the distance between these two values. So y2 plus y1 divided by 2 would give me the center of this differential element. My next task is to find the area. I know the width is dx. I know the bottom part of the rectangle is described by y1, the top part by y2. So the height would be y2 minus y1. I want to find the area of this differential element, so that would be the height times the width. So now that I have dA and x tilde and y tilde, I can plug it into my equations and find the centroid values. So x bar would be x tilde dA over dA. What is x tilde? Is x. dA would be y2 minus y1 dx. And dA would be y2 minus y1 dx. So each y2 and y1, they are described by x, they are function of x. So I'm going to plug in these values. y2 is x, y1 is 1 over 100 x squared dx. And the range is ranging from 0 to 100 millimeter. I'm not going to change it to meter. I'm going to keep it at 100 millimeter. And the value that I find at the end would be based on millimeter as well. Here I have 1x multiplied as well. Similarly for dA in the denominator. So I just need to take an integral. Here is function of x. So that would be 50 millimeter. The y bar would be y tilde dA over dA. Y tilde was y2 plus y1 divided by 2. dA is y2 minus y1 times dx. And dA is the same as what we found for x bar. Here we can simplify it further. I can take the half outside the integral. y2 plus y1, this parenthesis times this parenthesis, I can simplify it according to algebra. y2 squared minus y1 squared dx over dA. And the value here, just gonna keep it at dA, half y2 would be x squared y1, so that would be x to the fourth, 10 to the fourth, because I had 100, so 100 squared would be 10 to the fourth. Then after integration, 0 to 100, 0 to 100, y bar would be 40 millimeter. So x bar and y bar would be 50 and 40 millimeter.